Welcome back. So this is the second part of our super intro to Python. Um, so what we are going to do in this part is actually look at some of the dynamic aspects of Python. In the first part, we looked only at the static aspects, which are the comments, the different types of data that you can store in Python, and sets, lists, tuples, dictionaries, objects, etc. Today, we're going to actually see how the code actually gets organized in blocks and the different types of blocks that there are, and actually take a look at some, actual program. We're not actually going to start coding quite yet, but just looking at the basics. We're going to be starting to do real coding from the next video. But these are important to know the basics, the theories behind the language. All right, so the first thing you need to know how Python code is organized. Now, last time we saw that you have files in Python, and the files are usually, well, always ends with a .py typically, representing Python, and you can import classes, objects, functions from other files as you need. Okay. Inside the file, your code is organized in blocks. Now, other languages like Java, C++, Swift, they all use some sort of brackets, usually curly brackets, to start and end blocks. So what is nice about that is that you can actually organize your blocks yourself, how you want the blocks to look like, how the blocks should be formatted. If you want to put tons of stuff in a single line, great. Or if you want to divide things up into as many lines as you want, as long as your block starts with a curly bracket and ends with a matching curly bracket, you're good. Python does not use brackets to start and end blocks. It uses code indentation, which means, yes, code indentation is very important. So you can't write all your code, right at the front of the margin. You have to indent it appropriately, which is also kind of nice. It does make code look better. Of course, the bad news is that it's sometimes hard to know exactly where a block starts, where a block ends. But that's again another reason to use a good IDE, because usually the IDEs will give you tools to expand and contract blocks so that you can kind of look at only the things that you want to look at as you're coding. So a new block starts after a line that starts that block with a colon. Okay, so you don't create a new block just like that. Okay, you always have to create a new block because the statement that you're in requires a new block to start. Some examples of those statements are like decisions, if then else, right? If something happens, you create a new block. When you're doing a loop, so you create a for loop, colon, new block. And that block is the one that is going to loop for that for loop. And we'll see examples of those. The first example that we're going to see is making decisions. Of course, when you're writing an application, you will be looking at variables, and based on what's in that variable or based on what something happened with some sensor that you got, input that you got, somebody pushed a button, you were doing some calculations, and based on the result of the calculation, you'd be doing something. So basically, you'll be making decisions all the time, and decisions always start a block. So here's an example. Let's say I want to look at an ultrasonic sensor, and we will see ultrasonic sensors eventually. It takes a couple of pins to set that up. And an ultrasonic sensor is used to get the distance from an obstacle. So I want to call that just get distance operation on the sensor, and that gives me back the distance. Now, based on this distance, I want to do something. So that's where you're going to start a condition or a decision. So you will say if distance is less than 10. So my ultrasonic sensor code gives me a distance back in centimeters. So if less than 10 centimeters, I'm going to say you're too close. But what is important to note is that this if, the start of the if is in the same line as the previous statements. But right after this colon, the next line has to go a tab over. Okay, so that is important. So you're starting a new block here. So that's the new block. Then again, in decisions, you'd say if, and if that statement is that condition holds, you're going to do something. If it doesn't, you would do something else. Now you can have chains of these in one single statement. So you could say if distance less than 10, you do something. Else if distance is less than that, do something. Else if distance is less than that, do something, and so forth, right? In Python, you do that else if, you sort of merge that together and you call it elif. But it's the same thing, elif distance less than 50, again, colon. Notice that this elif is tabbed back to the same level as the if that it matches. And this is sort of a visual match that you're going to have to do because there's no brackets that tell you where the block starts and where it ends. This block starts after this colon, so everything inside this block is going to get a tab over. And then when you're done, you're going to tab back to the previous level and start the elif. And again, right after the colon, you're going to tab one over, and your IDE is going to help you with that. Whenever the IDE sees the colon, it's going to automatically tab over the next line. However, the IDE doesn't know when your block ends. So when you know that the block is done, you're going to have to hit backspace to go back that level. So you will need to go back to the level to start a new block. So that's your if then else statement. So you say if something, and then elif, some other condition, and you can have a whole bunch of elifs, and the last one is else. Of course, elifs and else are optional. If you do not need to worry about what happens if distance is not less than 10, you don't have to do anything. But in this case, we wanted to make sure that we cover all possible conditions. So that's why we have an if, an elif, and an else. The next thing we're going to do is we're going to learn how to do some repeats. Obviously, in code, you are going to be doing the same thing multiple times. Well, not necessarily the same thing, but things with maybe a little bit of difference each time you do it. So, for example, in many of the code that we'd be writing, we're going to be moving things around, right? So we can move a ball one step over, and then the next time we move it another step over, and move next another step over, and so forth. So when we do that, it would be best way to do that would be a loop, because a lot of times you do not know how many times you'd want to do, and copying paste code is never a good idea. So there are two different types of loops in Python. One is called a for loop that lets you repeat things when typically you know how many times you're going to repeat. Okay, or at least some way you can predetermine, or it's easier to just know the number of times to do this based on certain conditions. The other loop is where you don't know how many times you're going to loop. We're going to be looping until something happens, and you don't know when that would happen. So we will, while that condition holds true, we will keep doing this. Now, for both of these loops, you can actually come out of the loop anytime you want using the break statement. We're going to look at that way far in advance, but at least for now, at least you know that just because you started a for loop doesn't mean you have to do the number of times that you set at the beginning of the loop. Something happens and you need to get out, you can get out. Now, let's take a look at for loop. A for loop, as I said, it lets you do things a predetermined number of times. And you typically do that using a range in Python. So for example, you say for some index variable x in range 0, 10. And this gives you a list of values. And those values start with a 0 and it ends actually at 9. So this range 0, 10 tells you that I want something back that starts with a 0 and I want to finish when I hit 10. I don't even want the 10. I want to finish as soon as I hit the 10. So for x in range 0 to 10 is actually only left inclusive, which means 0 is included, 10 is not. And then inside, note that again, we tabbed one over. So this is a tab over. And in PowerPoint, it looks like this thing is a space over, but it's actually not. These two need to be exactly in the same line. Remember, even if there is one space, the compiler is likely going to complain. So unfortunately, sometimes PowerPoint, when you are dealing with multiple fonts, the placement don't look that perfect. So apologies for that. But again, you're starting a new block because you're ending that line with a colon. And so everything from then on until the end of the block will be one tab over from that previous line. You can also use a for loop for every element of a set or a list or a tuple, right? So last time we looked at this tuple called days, which had a list of strings representing days. And now what you could say is for some variable in, now instead of saying range, I just say for that variable day in days, just for all of these values. Then inside, notice that everything is a tab over. Now you're going to notice that this one is 2 tabs over. Why is that? Because this starts another block. So inside I have another block, which is started by a complex statement. Again, this is the decision. As you know, we have seen that a decision starts a new block. So we're going to have to tab this next line over one more. Now we tab 1 back to do the else. And then we tab 2 back to go back to the level of the 4 when we are done with the entire loop. So that's essentially how you do a for loop. So it's basically going to go through these days array or list. And then if day is either Saturday or Sunday, we're going to say that day is a holiday. Otherwise, it's going to say it's a school day. That's a simple little example. Let's take a look at while loop. As I said, a while loop is useful when you do not really know how many times you're going to loop beforehand. You're basically going to go on forever until something happens. Or sometimes in many of our microcontroller applications, we want the application to keep going on forever until you hit the power switch to turn it off, right? So then what we would do is while true, which basically means that this is going to go on forever. We will do something like we turn the light on, we wait for a little while, then turn the light off, and then again wait for another second. So this is going to keep blinking the light forever. Turn it on for a second, off for a second, on for a second, off for a second, and this is going to go on forever. Notice that since we do not know when this will ever end, well, in this case, this will never end, we use a while loop instead of a for loop. Now, maybe we don't want to do forever, but maybe when a sensor triggers it or something, right? So what we could do is we could say while the sensor is greater than 25, then at that point we do something. But the moment the sensor's distance becomes not greater than 25, so either 25 or less, it's going to come right out of the block and continue doing the rest of it. right? So while sensor is greater than 25, we keep moving. Now, the moment it fell below 25, we came out of the block. Now you say, ooh, too close. You need to stop. Right? So that's basically one way to use a while loop. The one last type of complex statement that we're going to look at are classes. And this is really one of the biggest things that we're going to be doing in this set of videos, object-oriented design. We are going to be creating our own classes and using classes from other libraries, right? And a class is also something that starts a new block. We're going to talk a lot more about classes and what they are in future videos, but right now, all we want to see is how to define a class and what are the typical things that are inside a class. So a Python class, you always use a keyword class. So define it, you will need class. And of course, you need a name. And then you also need some properties and sets of operations. We're going to be learning about what properties are, what operations are, and how to identify them eventually. But today we're just looking at the syntax. Now, Python, unfortunately, is not an object-oriented language by design. It was originally created to just be a functional programming language. It got its object-oriented properties around 2.7, I believe. Python 3 is, deeply object-oriented, but still it has its original non-object-oriented flavor. And there are many aspects of object-oriented design that are just not supported in Python. Okay, so for example, encapsulation, which is a term that you hear a lot in object-oriented design, where that allows you to hide or expose parts of your class to the external world. So you could say that I have some variables in my class that are private. Nobody outside the class can access these variables. Well, you can't do that in Python. In Python, everything is basically public. So we will see some ways you can get around it and tell Python interpreter to be a little nicer with your variables and things like that. Every class will need to have a special method called init, and that's actually underscore underscore init underscore underscore. Again, PowerPoint kind of merges the underscores together. So just remember that it's 2 underscores, then an init, another 2 underscores. And these things are little curiosities of Python that you'll have to deal with because, as I said, it's not originally designed to be an object-oriented language. So how do you create a class? Well, let's try to solve a simple little problem today to kind of give you an idea of what a class is. So let's say we want to build a traffic light that has 3 lights and you have some operations to light them in a specific order, right? Just like a traffic light works. And we're going to keep things simple. So just to demonstrate the concept of a class, we're not dealing with any of the more, nitty-gritties of this problem. Now, in this video series, we are going to be learning about UML, or Unified Markup Language, which is Unified Modeling Language, which is what is used for object-oriented designing. And but today, just realize that when you are doing and creating an object is basically represented with a rectangle, just a box. At the top, you say the name of the object or the class, and then the first sub box, you put all of your attributes or properties, and then the next sub box, you put all your operations. So my traffic light has 3 lights inside, which is a red, yellow, and blue, and then the operations are go, caution, stop, operate, things like that, right? And then the underscore underscore init, that essentially represents how do you initialize the class. So now let's take a look at actual code that show you how this traffic light is constructed. And this is just, just an example. So we're not doing a lot of logic here today, just to show you how we're putting together all the things that we have learned so far. First, a comment. First thing that we learned, right? You always start your code with comment and try to put as much documentation in your code as possible. In fact, we call these types of comments doc strings, and we are going to try to do these as much as possible, that when you create a new module or a new file, you put this multi-line comment with 3 quotes, ending with 3 quotes, and say, what does this file have? So anybody who finds this file and need to use it knows how to use that. Then the first set of things that you do is import stuff. We learned about that. We import the time module, and then from the lights module, we imported everything. So everything that's in the light module, now we have access to that. This is our first class definition, right? So that's how we create the class, and this is the start of our class definition. We are creating a class called traffic light. The first thing that we do is define this function, and this function, or actually inside a class, since we are inside a class, should be referred to as a method. And a method is, this method is underscore underscore init underscore underscore, and then it takes some parameters. We'll learn more about parameters as we go along, but the first parameter in every operation or every method is going to be this weird one called self. And that's, again, another Python characteristic. When you create a method inside a class, the first one will always have to be self. If you forget that, then it actually becomes a function and it will not work when you try to call it as a method. So be careful about that. Always put self as the first parameter of a method. Again, you have a comment that sort of describes what this method is going to do. And since the init method, the constructor, basically does some initialization. My traffic light has 3 lights, a red light, a yellow light, and a green light. So I initialize all of them, and I call the stop method. Now, I haven't defined it yet, but we will define it soon. But you can actually, in object-oriented design, remember, there is no concept of sequence when you are in object-oriented design. So you can actually call something that you haven't defined yet. So the compiler will look for this stop method as it goes through this code. So I'm calling stop. That's obviously going to stop. So we know the traffic light is in a known state of operation as soon as you create this traffic light. We do not, we need to know what the traffic light is doing at all times. So now let's go ahead and define this stop method. Now you can't tell in this code, but yeah, all of these are actually an indent level over. Remember that all of this start from the very left of the file or left of the margin. And then notice that the colon class traffic light indents this over, and then this colon again, everything inside is 2 indents over. And then when we go to the next one, 1 indent goes back. And again, from here, we are another indent over. So this is actually something you have to keep telling yourself, that you need to make sure that anytime there is a colon, the lines after that will have to be tabbed over. Now, as I said before, your IDE is going to help you with that. So when a traffic light stops, green and yellow goes off, red goes on, right? That's basically what it's doing. Caution is when the yellow comes on, and that's when the red is off, green is off, but the yellow comes on. That's essentially what caution is. And then go is basically red is off, yellow is off, and then green is on. And notice that each time we have specific comments to see what exactly this is doing. Of course, this is very rudimentary, but at least you have the idea of what exactly this class is doing. Now, let's say we create a method called operate. This is sort of the normal operation of your traffic light, where the light is just going to cycle through these lights at predetermined number of amount of time for each. So this is where you can start seeing use of these parameters. So operate, obviously the first parameter is self. Notice that all these stop, go, these guys don't have any other parameters. So when we call them, we'll just call with a stop. When we call them, we don't need to send the self that sort of comes in from the class that you're calling. Any other parameter you will have to provide. So here, we make this operate a little more reusable. So we are actually creating parameters saying that, hey, how long is the green light going to stay on? How long is the yellow light going to stay on? How long is the red light going to stay on? Okay, so these are the parameters that you can pass in, and that's how we are defining. We are going to start at green, so that's why it calls self.go. Then it sleeps for how long the green time is going to stay on. Once that is done, it's going to turn on the yellow light, and then it's going to sleep for so many seconds, and then it's going to turn on the red light, and then it's going to sleep for however long seconds it needs to sleep with the red light on. And that's just a single cycle of operation. It's not like a loop. It's just a single operation for the light. And sample main program, which is going to do the whole thing. We're going to first create an object, an instance of the traffic light class. And notice that we're passing in 3 things in the traffic light. What are those 3 things? Let's go back to the traffic light initializer. See, it takes 3 things: red pin, yellow pin, and the green pin. These are the pins, IO pins and of the Raspberry Pi Pico. And we're going to see what those IO pins are as we go forward. And then after we create the traffic light, I operate. And this goes on forever. Now, some of you will notice that, hey, I did not send any parameters. Operate takes 3 parameters, right? But what is nice about Python is that you can actually give default values to your parameters. In the initializer, we did not give default values. The R pin, Y pin, G pin there were no default values. So you had to explicitly specify what those values are when you created them. But here, we have default values: 5 seconds for green, 2 seconds for yellow, 5 seconds for red. So unless we need to change any of them, we could just say operate, and it's going to use the default values. And that is going to go on forever as long as you run the traffic light. So that's basically all we are doing for today. So what we learned is we looked at Python code blocks and the tab structure. So remember, that is extremely important. And many of you who are new with Python, as you work with Python, you will end up seeing error messages just because your code is not tabbed right. We saw how we make decisions with if, elif, and else. We saw how to repeat code using for loops and while loops. And we saw a very simple example of creating and operating with your own objects and classes. So that was useful, and we're going to see you soon in the next video.